Okay, so now we are going to kind of make things a little bit harder. So a composite shape is just it's just a combination of two shapes kind of put together. So if you look at this, this is an example of a composite shape, but it's made up of two shapes. So we have what is a rectangular prism here, and we have a cube right here. So if we could detach it, you could kind of see the separate shapes that would be involved. One rectangular prism, one cube, but together we have this kind of weird looking shape right here. Now when you're working these problems, I kind of want you to visualize in your head on how to be able to like kind of detach it and separate it into its own separate shapes, because it's going to make things a whole lot easier. So when we're solving this, so let's say we take basically the exact shape that we have and we have it right here. And the numbers might be a little iffy to see, so kind of bear with me on that. So we have this lovely rectangular prism and this cube that is right here. So I've kind of just made up the numbers to kind of make it a little bit easier to work with. Definitely not to scale and definitely not realistic, so just go with the flow. So step one in kind of solving volume of composite shapes, complex figures, whatever you want to say, it's kind of basically break apart into kind of separate shapes. So what I mean by that is, like I said, visually detach this into two separate figures. So one shape, two shape. So if I was to work this out on paper and draw, I would kind of break this into its own separate shape. So my rectangular prism. And then my lovely cube. So if I'm looking at this, I also have to look at the measurements that go with each thing. So if I look at my first shape, shape 1, I can look at this and notice that I do not have the height of my rectangular prism. However, I do have enough information in the problem that can help me figure that out. So I'll come back to that in a minute. So I have my width here, which is 2 feet. So I know that this width, length, whatever you want to call it, is 2 feet. Then this side right here, the width is 6 feet right there. And the height, that's the kind of mystery side that we've got to come back and kind of figure out that we're kind of missing. But like I said, we do have enough information to solve that, which I'll get to kind of here in a minute. If I look at my cube, I notice that I have all the measurements that I need. I have 6 feet by 6 feet by 6 feet. So that one is a little quite simple. So kind of step 2, which kind of brings me to that, is going to be finding the mystery measurements. You won't always have to do this, but sometimes you will, and it's just you have to use your understanding of parallel lines and kind of with the shape and using what's given to you to kind of solve these. So the only side that we're missing is the height of this rectangular prism. So if we look at this, I have my cube, which has a height of 6 feet. Now I know the entire composite shape is a total height of 15 feet. So if I know that this portion right here is 6 feet, well 6 plus something gives me 15. So if I did that, that would be 15 take away 6, which would give you a height of 9 feet. So I now know that this height is equal to 9 feet. I now have the measurements of all my sides, lengths, heights. So now all I have to do is step 3, which is calculate the individual volumes of each figure. So if I start that, step 3, calculate the volumes. So my shape 1 and forgive my terrible drawing in this. We have 9 feet by 6 feet by 2 feet. Volume equals length times width times height, which when I plug this in, it's going to be 2 feet times 6 feet times 9 feet. 6 times 2 is 12 feet. And like I said before, when we have feet times feet, that's feet squared, square feet. We have not done anything with the 9, so we bring that down. That's 9 feet. 12 times 9. For those of us that kind of struggle with multiplication, 9 times 2, we know that that's 18, carry my 1. 9 times 1 is 9, plus 1 makes 10. So this is 108 feet cubed, cubic feet, whatever you want to say. So that's for shape 1. For shape 2, which is our cube, we had 6 feet by 6 feet by 6 feet. So the same thing, if we do the formula, the algorithm, volume equals length times width times height, which that is then going to be 6 feet times 6 feet times 6 feet, and I'm shrinking. So 6 times 6 is 36 square feet times another 6. I don't know that off the top of my head, so I'm going to step out and I'm going to do a multiplication problem. So 36 times 6. 6 times 6 is 36, carry 3. 6 times 3 is 18, plus 3 makes 21. So we have found the volume of the cube, which is 216 cubic feet. However, you are not done, because step 4 is you've got to add both of these individual volumes together. So when you do that, step 4 is just put it all together. So now we have 108 plus 216. Now when you are solving this, I hope you're way more organized than what I'm doing. I'm kind of running out of space, so I'm kind of squeezing it together. 8 plus 6 is 14. Carry my 1. 1 plus 0 plus 1 makes 2. And 2 plus 1 is 3. So my final total volume answer is 324 cubic feet.